All right, continuing on as we move through this series, we've been talking about the calculation properties. We talked about DE stop, DE stop on FOV, the ray stop multiplier. Step width limiter doesn't really have much of an impact anymore, but it's there. I haven't really found it to make much of a difference in my quality. Now, the step count for binary search, your default is 8. I really haven't found that I need to modify that all that much. Step count for binary search. Now, essentially what that means, let's get back into our drawing tablet here. Okay, so you know, I had talked about the idea here is to not overshoot your the object. Don't overshoot it. If you overshoot it, then that particular ray doesn't understand where the object is in the scene. Okay. Okay. Now, the step count for binary search basically says this. Don't just settle for that one ray hit to determine where that object is in the scene. Do it again. Hit it again. All right? In this case, have that ray go out 8 times on that same spot to improve the accuracy of where it actually hits. So this particular setting is an internal, it's a property for internal processing that will assist the algorithm of the software to be more accurate as to where the ray actually hits. Step count, okay? And now, the rule of thumb is this. The higher this value is, the more accurate the ray is in determining where an object is in the scene. All right, your typical default is 8. Okay, now in real life, here's basically what it means, is that if you're getting a lot of oversampling, there's a lot of white dots everywhere, and you have found that your DE stop and your ray step multiplier, the two that are most important in terms of overstepping, are not enough. You can't really settle it in, and you're not happy with the quantity of white dots that you're getting, and you can't solve it with these two properties, come on down here and punch this up. All right, and they say that 12 is, you don't normally ever need anything more than 12. All right, and I think what they're trying to say is, look, if you punch 99 in there, you're just wasting computer horsepower. It's not going to do you much better. All right, so the rule of thumb is this: with this particular one, just leave it on 8. Try to get your quality and minimum oversampling accomplished with your DE stop and the ray step multiplier. If you can't, then go ahead and tweak this up, whereas higher would be better quality or less oversampling. All right, but you could easily run with this thing way down here. Okay, if these two properties are handling your issues, then you really don't need the step count to be much higher than, say, 8. That's basically what they say. All right. Now, smooth normals. Let's go back to our little chart here. All right, now basically, let's just take an object. Okay, this is a Mandelbulb 3D object represented in a 2D flat plane here. Now a normal, which I'll make red, is actually it's a ray, or it's a vector, or I don't know, a line. This is all math that is exactly perpendicular to the surface of which the ray is hit. All right. So let's take this one right here. So the normal on this position would be straight out like that. The normal on this right here would be something like this. Look, I'm getting straight lines there, okay? All right, so a normal is the measurement that is exactly perpendicular to the surface angle. So what this is saying is that the higher the number, the more accurate the normals are calculated within your scene. All right. So if it's a low number, it's just normal. It's just nominal. It's just what the thing does. If I punched it up, you see, well, something like that. If I punched it up, then the internal software is going to really pay attention to make sure that that angle is exactly 90 degrees or normal. All right, now what it comes down to is this. I have found, and basically they say, that 2 is your normal. The software does a pretty good job in determining normals, or I should say the accuracy of normals, with a value of 2. And that should be sufficient. And they say that basically if you're getting your rendering isn't really looking all that great. It's a little rough, a little dicey. You could try increasing this value here to try to improve the accuracy of the normals, because the normals, the calculation of the normals does have a lot to do with this ray marching. It really does. The internal software algorithm needs to understand angles, all right, because that's part of calculating where the objects are in your scene. All right, when the ray hits that, part of that calculation is for the software to determine the normal. That is the right angle, the perpendicular angle of from the object, and that is a big part of your ray tracing, your ray marching methodology. So the rule of thumb is that the smooth normals can be left at 2. If you find that the image is a little rough, a little not quite as accurate and detailed as you want, and you have tried the DE stop, the ray stop multiplier, and even the step count, you've tried those, then go for the smooth normals and see if you can further optimize. As with the others, the higher your smooth normals value, the longer the render. All right, so we'll stop here. We'll cover these others here in the next session. I'll see you there.